Okay, so the first exercise I'm going to take you through this week is exercise 251 on page 84, where we have a graph and it asks us to create a table of values. So that's going to be what our solution looks like, a table of values. So we'll have the form like this. And it's worth noting that in the table of values, it's conventional for on the right hand side to be the x variable. So the one that's on the x-axis, which is of course your independent variable, which in this case is r, which we can read off of the x-axis of the graph in the book. Therefore, on this side, on the right-hand side, it's conventional for your dependent variable to be over here. So the variable that's denoted on the y-axis in the book, in this case capital T. And we're asked to construct this table of values from negative 1.5 up to 2.5 at a pace of 0.5 each time. So negative 1, negative 0.5, 0, 0.5, 1, 1.5, 2, 2.5. And it's worth noting that we have the symbols in the book that includes both negative 1.5 and 2.5. If we didn't have those little lines under the symbols, then don't waste your time including those parts. Then, all we need to do is take a look at the graph, find these values on the x-axis, and see what the corresponding y value is. And it's helpful that these points are plotted in bold. So we just need to find, we have minus 1.5 for r, then we go up to meet the graph, till we get to, it's probably about 1.35, 1.4, let's say 1.4 for negative 1.5. Then negative 1, the graph has dropped steeply between those 2 points, so that gives us a value of negative 0.5. At negative 0.5, we probably have about negative 1.25, or no, 1.2, sorry. At 0, the graph crosses the axis at negative 1. At 0.5, we've probably got about negative 0.3. At 1, we go through 0.5. At 1.5, we have about 1.1. At 2, we have exactly 1. And at 2.5, we probably have negative 0.1, let's say. It's worth noting that in these types of exercises, on your final exams, there's a boundary, a bound between which you're allowed to have your results. So, for example, they might say for this one that they'll accept anything between minus 0.05 and minus 0.15, for example. So if you get anywhere within that range, it's fine. But I would always recommend using a ruler to make these as accurate as possible. So that's all we needed to do for exercise 251. Let's move on to 252E on the same page. So in this exercise, we need to create a table of values for our function g of x is equal to the square root of x squared minus 2 for x between minus 5 and 5. So here I'll put my x on the left hand side again, just as I did in the last question, and now what we get out is g of x. Or you could label this one y if you wanted to. So let's go for a step value of 1, so negative 5, negative 4, negative 3. So, let's see. We have then x squared minus 2 each time. So for negative 5, that means the square root of negative 5 squared minus 2, which is the square root of 25 minus 2, which is the square root of 23. Now you can use your calculator to calculate this and find it to 2 decimal places, but actually this is more accurate, so we'll just leave this as our answer, root 23. If we were going to plot the graph, it would be helpful to use the calculator to find the actual number, so that we could know where to plot our point, but at the moment this is the most accurate way. So again for negative 4. Negative 4 squared is 16, minus 2 is 14, so we have root 14. And please make sure each time you square the negative numbers you end up with a positive number, otherwise your function will be undefined a lot of places. So for negative 3 we have 9 take 2, which is root 7. For negative 2 we have 4 take 2, which is the root of 2, which as we know is irrational. For negative 1, however, we have the square root of 1 minus 2, which is the square root of negative 1, which doesn't exist. So our function here is undefined at this point. The same for 0. 0 minus 2 is minus 2, so the root of negative 2 is also undefined. And we'll find the same for 1. Then if you carry on, you'll notice that you get exactly the same results again. Because we're squaring these numbers, the square root of 2 is the same as the square root of negative 2, we'll get exactly the same results again, so I don't even need to calculate them. I'll get negative 2, negative 7, or the square root of 2, the square root of 7, sorry, negatives on the brain, square root of 14, and the square root of 23, and we're done. Hopefully you were able to construct this table of values and 252a on your own. So, turning over the page, let's go on to 258. This question then has 3 parts, and they're all related to the first graph that you can see at the top of page 84. So, we need to know, first of all, for which u is the function of u equal to 0. So, all we need to do here is, if I do a little sketch of the graph, we have it kind of goes like this, and then up, like that. We need to find out at which point the function value is equal to 0. So this is u, and this is h of u. And h of u is 0 along the x-axis, or in this case the u-axis. So we need to find this point here and this point here. As we have 2 solutions, I'll number them. Our first one is u1, which looks to be negative 2.5. And our second one, u2, is at 1. So for both of these values of u, the function value is 0. B asks us for which positive u, so for which u greater than 0, is the function value greater than or equal to 1. Here I need to look at when the function value is 1, and I'm interested then in the area above that point. So from this u onwards. And I can say, looking at the graph, that this is the point 2. So when u is bigger than 2, then h of u, or bigger than or equal to 2, then h of u is greater than or equal to 1. Then C, for which u does h have a minimum value, is the value of the function minimal? Well, then we need to have a look at when h is minimal, and that's at this kind of point here. So we need to go up to have a look at where that is. And I make it to be about negative 1. Again, it's difficult to see, but I'm going to say u is equal to negative 1. Later on, we'll learn how to find this by calculation in a couple of years' time. Okay, so that's 258 done. Next, I want to have a look at 260, which is related to the second diagram, the middle diagram, and this just asks us for which x is the second function bigger than the first function, greater than the first function. So you can see that the second function is the blue line and the first one is the red line, and you can see that the blue line becomes larger than the red one when x is greater than 3. So this is your solution for 260. Then we have 261. So we need to find for the third one, when is the value of the function 0? So when is g of x 0, for which x is the answer that we're looking for? This one's worded a little bit weirdly, so that's why I wanted to go through that one with you. So again, here we just have a look along the x-axis and see where it crosses the x-axis, because that's when our value of the function is 0. And again, we have two solutions. So x1 is negative 2.5, and x2 is positive 2.5. The second part of this question asks us when the value of the function is 1. And then we have a look for when the points where the value is 1, so 1 on the y-axis. And we find again 2 points where this happens. So the first one is at minus 0.5. And the second one is at 2. Finally, we need to find when the value of the function is at a maximum. And you can see that the maximum is 2. So we're looking at when g of x is equal to 2. And the x value for this is when x is equal to 1. So these are our three solutions for 261. Finally, let's take a look at 263. And actually, because this one's quite a long one, I'll put this one in the second video for you.